Hello students, welcome to Learn It. As far as the competitive exams are concerned, electrochemical series is the important segment. So students must understand two things. First one, fluorine is at the top and lithium is at the bottom. So this is the first thing. And with respect to fluorine, it is the most electronegative element. Lithium, it is the electropositive element. These two things students must know. And what is an electronegative element? Electronegative element can be easily understood by one example. Consider any metal which approaches to fluorine. Then this fluorine takes the electron from this metal forcefully. It means that this fluorine makes this substance to undergo oxidation. Then fluorine acts as an oxidizing agent. But with respect to lithium is having one electron. It is 1s2, 2s1. It doesn't want this electron. So if it is approached by any substance or any other metal, then it forcefully gives this electron to that. So it makes, this lithium makes other substance to undergo reduction. So that's why lithium is the strongest reducing agent. So at the top we have the oxidizing agent, at the bottom we have the reducing agent. With the help of this knowledge, we are going to our next study, that is applications of electrochemical series. It means what is the use of this electrochemical series. The first one is to predict the relative strengths of oxidizing and reducing agents. Second one is to predict the feasibility of a reaction. Third one is calculation of EMF of the cell. Fourth one is to predict whether a metal can liberate hydrogen from acid or not. So let's discuss the first one. We can predict the relative strength of oxidizing and reducing agents by using the electrochemical series. So here it is already given that oxidizing strength, it is in the order of H2O2 is at the first, then KMnO4, then K2Cr2O7. So oxidizing strength of hydrogen peroxide is more than the KMnO4 than the K2Cr2O7. We can confirm it by using the electrochemical series. So here we already know that oxidizing strength is highest at the top. So we need to check from top to bottom whether the series is correct or not. So here at the third position we have hydrogen peroxide. So hydrogen peroxide is number 1. Then comes the MnO4 minus. So MnO4 minus, it comes from KMnO4. So it is at the second. Next comes the K2Cr2O7, that is Cr2O7 minus 2 comes from K2Cr2O7. This is at the third. So by this electrochemical series we can predict the relative oxidizing strength. In another way we can discuss this relative strength of oxidizing and reducing agent is by using the values. So they may give like E naught of MnO4 minus 2 Mn plus 2. Here the student must know or predict what is the change in oxidation state. So here it is plus 7, here it is plus 2. So plus 7 to plus 2 means it is reduction. So plus 7 to plus 2 means there will be accepting of 5 electrons. So it is reduction. So if they give like EMnO4 minus 2Mn plus 2, then it is the standard reduction potential. Its value is 1.49. So with respect to relative strength of reducing agent, we know lithium is the strongest reducing agent. So any reducing agent with lithium, like lithium aluminum hydride, it is the strongest reducing agent. Then we already have sodium in ethyl alcohol. It is less stronger reducing agent than lithium aluminum hydride. The relative strength of reducing agents is used in metallurgical operations or in the purification of metals from metal oxides. So here we have aluminum oxide. It is called as alumina. So from alumina to aluminum we use reducing agent. So how to select the reducing agent? So here it is the aluminum, and all the metals which are below this aluminum in this electrochemical series can act as a reducing agents. So we can use the magnesium, we can use the calcium, we can use the barium, because others also can be used, but they are having the negative impacts. So here generally magnesium is used. It means magnesium metal is used. Second application of electrochemical series is predicting the feasibility of a reaction. So here we have copper solid which is in contact with aqueous Ag+ ions. It means we have Ag+ solution, in that copper rod is inserted. This is a redox reaction. Whether this reduction is possible or not can be predicted by using the electrochemical series. We know that Cu plus 2 to Cu can happen. That we know that E naught of Cu plus 2 to Cu is having the value 0.34 volt. In the same way, E naught of Ag plus to Ag, which is having the value 0.80 volt. So it means the reduction potential of silver electrode is more. Silver electrode is more. Means that when Ag+ ions are in contact with copper, then they can grab the electrons from copper. So this reaction is feasible and it can be understood by this graphical image. Here this solution is containing Ag+ ions and this is the copper metal. We can see deposition of silver over here and the solution is turning into pale blue. So pale blue indicates the Cu plus 2 ion. So there is an oxidation of copper into Cu plus 2 and reduction of Ag plus ion into Ag simultaneously. But when we put silver rod into copper plus 2 solution, this reaction doesn't happen. Next application of electrochemical series is calculating the EMF of the cell. So consider the cell. It is never used before, and the potential difference between the terminals of this electrode is called as EMF because it is never used. It is the highest potential difference between the terminals of the cell or battery. So EMF is more in the beginning, but then when we start to use the EMF, this is EMF, but when we start to use it, its energy or its potential difference decreases. Now this is called as potential of cell or cell potential. So EMF of the cell can be calculated by using the formula E naught of the cell. E naught of the cell is EMF of the cell, which is equal to E naught of cathode minus E naught of anode. So this is the Daniell cell. So Daniell cell consisting zinc and copper electrodes, which are connected by salt bridge. Here E naught of the cell, that is EMF of the cell, is equal to E naught of cathode. So here copper acts as a cathode and zinc acts as an anode. So standard reduction potential of copper electrode is 0.34 volt minus standard reduction of potential of zinc electrode is minus 0.76. That's why we get the 1.1 volt. Next application of electrochemical series is to predict whether a metal can liberate hydrogen from acid or not. So consider a vessel in which acid is present, which should convert into hydrogen from certain metal. So this H plus will convert into H2 by using this metal. It happens when this metal has to give an electron to H plus. When does this happen? So this happens when this metal should undergo oxidation. It means that this metal should be having oxidation potential, or it should have negative reduction potential. E naught for H plus to H2 is 0. So all the metals which are below standard hydrogen electrode can displace the hydrogen from acid. So this completes the applications of electrochemical series.